Hello everyone and welcome to my channel Chemistry Class. So this is series 1 and part 14. So today we are going to discuss about pH scale and types of indicators, and also we are going to learn the values of the different substances present in our home. The pH values we will be knowing today. So first let us see what is a pH scale and what does it say. pH scale is a scale which basically tells us the strength of an acid or a base. And you must have wondered, what does the P in pH stands for? It stands for potens, which in German means power or potential. So power of H plus ions. As you all know, H plus ions increases, the acidic nature of the solution also increases. Universal indicator applied to a paper is used to measure the pH. Once again I am reading carefully. Universal indicator applied to a paper is used to measure the pH. So what do we use here to measure the pH value? We use universal indicator which is applied to a paper. So in this video at the end we will be knowing what is the meaning of universal indicator. Before that, let us see what are indicators. Indicators are nothing but substances which are used to show the acidic or basic nature of another substance are called as indicators. I'll repeat once again, please carefully listen. Substances which are used to show the acidic or basic nature of another substance are called as indicators. And coming to types of indicators, there are 4 types of indicators: natural, olfactory, synthetic, universal. So first let us discuss about natural indicator. What is a natural indicator? Indicator obtained from natural sources are called natural indicators. For example, litmus and turmeric. In the previous videos we have discussed how litmus is obtained. You must have known that litmus is obtained from lichens. And litmus paper, it turns blue litmus to red. The acid, it turns blue litmus to red, and base, if it's a base, the red litmus turns to blue. I have discussed about litmus paper in the previous videos, so those who did not understand this can watch my previous videos. And coming to olfactory type of indicator, substances which change their smell when mixed with acid or base are called olfactory indicators. That means if you add this substance to acid or a base, the smell automatically changes, and that is what is olfactory indicator. For example, paste of onion loses its smell when added with a base. That means if you make onion paste and add it to a base means which has pH value of 7 to 14, 7 is neutral and 8 to 14, and if you add paste of onion in that solution, and the onion loses its smell because it is added to a base. But when you add the same onion paste to an acid, the smell does not change. So that's what you need to remember here. And olfactory indicators, they are used in laboratory for visually impaired students. I have written here visually impaired students. That means those who cannot see properly, those do not have clear vision. For them these kind of olfactory indicators are used. So coming to synthetic indicators. Synthetic indicators are synthesized in the laboratory. That means they are prepared in the laboratory. So phenolphthalein, as I have discussed in the previous video, phenolphthalein turns pink when you add it to a base, and it stays colorless when you add it to an acid. I repeat once again, phenolphthalein, it turns pink when you add it to a base, and it stays colorless when you add it to an acid. And methyl orange turns yellow when you add to a base and turns red to when you add to an acid. Turns yellow to a base and turns red to an acid. So these indicators tell only the acidic or basic character of a solution. As you have observed, this phenolphthalein or methyl orange or any other kind of indicators, the natural or olfactory or synthetic, they only tell the acidic or basic character of the solution, but we cannot know the strength of acid or base. So let us look at the universal indicator. Universal indicator, the example is pH scale. As you have already known that 0 to 6 values in pH scale is acidic, 7 is neutral, and 8 to 14 is basic. And down I have written some examples to tell the pH values of those which are present already in our body and in our kitchen and daily life. If you know gastric juice, the gastric acid, it is an acid because the pH value is 1.2. That means it's very strong acid. And lemon juice pH is 2.2 to 2.4. That is also a very strong acid. And coming to coffee, it is weakly acidic because pH is 5 and 5 is very closer to 7 and 7 is neutral. And coming to neutral, distilled water is neutral because its pH is exactly equal to 7. So that's why distilled water is neutral and it's not an acid or not a base. And human blood is not an acid because human blood pH value is more than 7. It is 7.3 to 7.5. And coming to baking soda, I have already told you the formula of baking soda in the previous videos that it is NaHCO3 for baking soda. And sodium carbonate is Na2CO3. Please don't get confused with baking soda and sodium carbonate. And coming to the pH value of baking soda, it is 8.3. And ammonia, the pH is 12. 12 means very basic because it is very near to the 14. 14 is the highest value of the basic character. And the most strongest base is sodium hydroxide because the pH of sodium hydroxide, NaOH, the formula of sodium hydroxide is NaOH. So sodium hydroxide's pH value is 14. That means it is extremely basic. So that's all for today's class. I hope you all liked my video, and if you have any doubts you can ask me in the comment section down below. But please don't forget to subscribe to my channel and also share it to those students who may find these videos helpful. And in the next video we'll be learning the use of pH in everyday life. So until then, bye, and also please share my channel and subscribe to my channel. Thank you very much for your patient listening.